We are live. Welcome, everybody. We are discussing tonight cold electricity versus hot electricity. It is the hot topic. I have Phase Matters, JP, and Mike Faraday Research with me tonight, and I'll let you guys take it away.
Yeah, so earlier we were discussing, quite a few systems, magnetic pulse systems, their ability to generate over unity outputs by adding transducers, what the difference between cold electricity and hot electricity is, and how we can actually create a system where we get to control which side we're using. And so I'd say let's start from a basic update from Mike, since he's going to be in the latest time schedule here. So what you got going on there in your recent?
So basically, actually, I'm going to start it off with a question for you. So I'm using the transducer in line hooked up in parallel with the coil. Now, before I had the transducer hooked up to it, my voltage output was very minimal. I was just basically getting back EMF pulses. And then when I hooked up the transducer to it in parallel with the coil, it came alive, and I mean really alive. Now, is there a situation that I had with the coil of capacitive inductance in the coil, and now the transducer is releasing that extra power stored in?
Yeah, the answer is absolutely yes. So adding the transducer, in your case, these are piezoelectric transducers, commonly available on eBay or Amazon. So these small little transducers are designed to go in fire alarms and alarm clocks and various other things, 25 millimeters, if I remember correctly.
Yeah, I'm using the larger one now. The one I have is 40 kilohertz at 60 watts. So these are the higher, they're the quite large ones.
Are these the thick disc type transducers, or are these still?
Yeah, they're the thick ones, the titanate, barium titanate, or whatever it is.
Yeah, what are the dimensions on that transducer?
The base of it's about 1.25 inches diameter, and they're each there's two of them separated by 2 copper plates for the anode and cathode, and they're about, I would say, about 3/8 of an inch thickness on each of them. So there's two of them in between the two plates.
Yeah, those were recommended.
It's in the top right. Yeah, that's the same one that Norman Wu-Tan was using. So I got those ones.
No, that's excellent. Yeah, those are very nice because they have a large enough capacitance to be quite functional. They have a high enough voltage operating range where back EMF impedance match actually does make sense for a coil of reasonable caliber, like ones we're looking at on the video right now.
Yeah.
And so in a normal coil back EMF capture system, you would want to really shunt the output potential of your back EMF impulse.
Yeah.
So here's one of those little quirky things about the BH curve of ferrite cores and the way that they respond, or not just ferrites, but I mean iron cores, any kind of core material basically at all to increase your magnetic permeability. Those materials, they take a little while to build up a magnetic flux as the atomic dipole moment realigns. The magnetic dipole moment realigns based on your solenoid coil's input power. But then, of course, when you no longer have current flowing, the flux that has been released or radiated from your coil, going out into the environment, now all has to collapse back in so that the system self-gauges. And it's in this space-time regaging where all of the magnetic flux, as long as it's in the same physical geometric position to its surrounding environment, when the back EMF collapses back in, that flux has to all come back in. Right. And it affects other things because it's a very, very fast wavefront in a asymmetric way. So during the charging phase, when you're building up the flux, it has a very long, slow wavelength with a very minimal amps per meter. But during the back EMF influx, the amps per meter and the volts per meter become very, very high. The problem is that the coil itself has interwinding capacitance, and this is where all of the losses would otherwise occur. But by
Right.
adding the transducers in parallel with the coils, what you're effectively doing is slowing down the impulse, and you're also doing something really special with it. This is what Wooten discovered. You're displacing the impulse mechanically, which means
Right.
that it's not in the same exact place in its space where it produced this pulse. It's by changing its position that it now changes its relationship with the back EMF field that has to collapse back in, because it is in a physically different space, which means that the waveform it receives from the influx of this self-gauging space-time is now going to be in a new spot, and so the energy it receives is going to be slightly different than the energy that it radiated.
Right.
That's really where some of the gains are that he was getting from his transducers, using barium ferrite magnets as one of his first oscillating transducer mechanisms, and then finally adding to that barium ferrite magnet, barium titanate transducer. And when you get both of those two things together and get them in resonance, you can develop the perfect phase shift between them.
Oh
So
yeah, it was a
that you,
huge. It was a very large phase shift and a huge gain in output power. And how about current? Is that also enhanced current at all?
current is unfortunately one of those balancing factors where you now have the fields enticing the flow for your charged particles that are moving through your wires. So you have two kinds of flow, right? You've got your electric field and magnetic
Mhm.
flux flow that travels in the space around your conductors, and then you have your actual current flow through the conductors, which is called electron drift. And electron drift velocities for copper and other conductors are extremely, extremely slow. So the fields they generate are actually incredibly weak. The electric fields, anyways. The magnetic
Right.
fields are strong, but the electric fields are weak. But when the entire coil, for example, has a bias against its surrounding environment, where it's either becoming continuously more negative or continuously more positive, its electron drift velocity in terms of the current that flows through it will not be linear, meaning that a coil would appear to either have more resistance or less resistance, depending on whether or not it was biased during its impulse with a positive or negative potential. And this is because we're basically imbalancing the number of electrons that are in the system versus protons that are in the system. If we have too many electrons, they don't have to move very far in order to produce their electric field.
Right.
But if we don't have enough electrons, let's say the coil is positively charged, well, now they actually have to move significantly faster and flow through the wire, and they're going to now produce a bit of heat.
Yeah, my motor is not exhibiting any heat whatsoever. None.
And sometimes even
Like
a reduction in temperature and local surrounding heat.
yeah, but see, since I've been doing the setup I've been doing, I never get heat in my coil at all. If anything, it gets a little bit cooler than ambient.
Yeah, and that
Now,
tells me you're probably running at somewhat of a potential bias compared to your surrounding environment, at least during each pulse.
right? Because yeah, like I said, there's no heat in that coil at all. It's basically neutral.
I've noticed something extremely similar too.
And we were before we went on air, we were talking about um, the destruction of the dipole, and that the circuits and systems that you make are designed to keep them in phase and in structure, and not constantly break them and go against them, as a difference between the
Yeah,
hot and the cold.
that's why I kind of had a renaissance. What do you call it? What's the word I'm looking for?
Epiphany?
Realization,
Epiphany?
epiphany. There you go. There's a good word. Epiphany. That I have to go to a way larger coil. Like I was working with coils that were 300 windings. So the new motor, my coil is 2.2 pounds. So I've gone way bigger, a lot more windings. I'm trying to create kind of the same effect that Joseph Newman he was working on. High voltage input, but very, very little current. He says the current is generated in the coil, so therefore all you need is potential going in, not current. That's why his 7,000-pound motor was running on these tiny 9-volt batteries. He had 84 of them hooked up in parallel. He was getting about 460 volts out of it, and he was able to move a 7,000-pound motor for over 4 hours. So,
Yeah, it was
impressive.
amazing. I seen that video too. What Newman discovered is a way around the latching problem. So when you have a magnetic stator, magnetic rotor, whether or not you have permanent magnets or you have solenoids or coils or whatever windings on both, you end up with this issue where there are little gaps between the stator core windings and the rotor core windings, and so you tend to have areas of higher magnetic attraction and lower magnetic attraction based on how what time it is on the dial of what position that rotor's in, and that's part of the problem. So this latching issue, what he discovered is you would normally need to power factor correct, as in you'd put a parallel capacitor in line with your coils of your motor in order to get the two to oscillate like an LC. But he found that if he just used simply far too many windings from any kind of conventional engineering principle, that the interwinding capacitance would slow that signal down to the point where at the RPMs he was running, he would be within a resonance range or within the right capacitance range, where power factor correction would automatically be happening within the windings themselves. And since he wanted to kind of keep those two indices, that permeativity and permeability, within the same region, the great part is by using the interwinding capacitance as an advantage instead of a detriment, which in most of your experiments, Mike, it actually is a detriment. But in Newman's experiments, it was an advantage because of the way that he had been using it. Then he was able to slow that signal down to the point where it wasn't being radiated off, but instead it was basically trapped within that system and continued to oscillate, so he was not losing the energy. And that's how he was able to use a fairly small amount of electrical input, current, and voltage in order to produce a continuous motion, since the motor itself was building it up during the part where it didn't have much resistance at all, and then releasing it back into the motor during the times where it did have high resistance to overcome.
Right. Yeah. Now, how about I'm using the spark gap switch, or basically the make and break switch, instead of using like a stator. And it seems to be working for me because I can get a huge amount of torque out of the motor and a huge amount of speed. Like I can get it up to over 2000 RPM, no problem, on 100 milliamps. So obviously I'm doing something correct here. Sometimes I don't always recognize what I'm doing. Trying to decipher exactly what I have actually accomplished.
Well, that's it's actually a really relevant question. Spark gap
I feel
versus
that.
spark gap versus commutator versus electronic switch. Electronic switches are obviously their own category. We kind of have a general idea about how fast they can switch. And in the electronics industry, for those who don't know and haven't had to deal with MOSFETs, transistors, and IGBTs, there's a trade-off. So you can get higher current through a semiconductor for the same size package and about the same cost, but you sacrifice the speed. And this is the great downfall of semiconductors as they stand in modern day industry for reasonable price. I did a series of tests using an oscilloscope and a fast disconnect system with extremely low impedance, extremely low inductance, and just verified how the system was going to operate based on types of disconnect switches, because I was looking for the maximum gain in potential in order to create an extremely fast transient impulse. And what I did is I tested those three compared to each other. I tested a spark gap, commutator, and the fastest transistor switch that I could find, because transistors are generally many times faster than even some of the quickest MOSFETs or IGBTs or other components. So I used basically the fastest solid-state switch that I could find. And by comparison, that fastest solid-state switch, I got a transition on my power carrying about 1 amp average for all these tests of about roughly 10.5 nanoseconds rise time, but it had pretty long curves from where it first came up to about the 10% level to the 90% level. It went at about 10.5 nanoseconds in that time, but that rise before it reached the 10 to 90, it was pretty long with the semiconductor, with the transistor. I then tried it with a commutator, and it was so noisy that I got ultra fast disconnects down to the 2 to 4 nanoseconds range, but it was unfortunately jittering because it was mechanical, and so that was an issue. Then I tried the Spark app, and with the Spark app, it was an optimized Spark app, meaning that it had a wide surface electrode area, a non-vaporizing material that was rated for high temperature, so we didn't end up with metal vapor that continued to conduct, and it was very smooth, so we didn't have loose emission points for ionization. In that system, I got down to the range of 0.5 nanoseconds, which is 500 picoseconds, up to about 2 nanoseconds switching time. When you compare that and then think about the simultaneous fact that the Spark app's capability of carrying current is probably about 100 times greater than that same semiconductor that was capable of operating extremely quick, then you realize the usefulness of Spark apps and why they can do things that, well, quite simply, we can't do with semiconductors at all.
Yeah, so I'm not crazy.
Well, I can't promise that, but not about this, at least.
Well, it just seems very obvious. It works way better in my system because I have tried high speed switches in my system, and the second I put my hand on the rotor and slow it down, it starts drawing huge amount of current. That means Lenz's law is taking effect. So when I've switched to the Spark app switch, I'm using the 12-volt relay switch you buy, at Canadian Tire or Automart. It's night and day. I could grab that rotor, slow it down, and it doesn't draw any more current. It stays the same.
All right. My guess is that you probably got your timing set so that you're not actually set up to draw any current whatsoever on the forward charging. So in whatever direction you actually are putting energy into your solenoids, I'm guessing you're not drawing energy during that part of the phase, and then it's only during the disconnect that your system turns on and actually can draw energy, if I would guess. And that's probably why
it's isolated.
Right. Yeah. So you're speeding it up just a little bit. People might, there's no way to see it in the video, but yeah, your rotor speeds up just a little bit, and then its gaining momentum, its acceleration is then used to generate a EMF in your coils during the separate part of the phase. And so, of course, you could never possibly see really a good coupling between your input and output power. And so you could load it down all day, almost short it out, and you would probably not see much of a difference, except for the fact that, maybe your coils will stay on longer if the RPM becomes too slow.
Yeah, exactly. Yeah, you're right. So it seems to work for the system. And what I'm very surprised about, like pulse motors are not really known for it to be torquey. My system surprisingly is very torquey. I'm getting a lot of power, like you have to really hold that shaft down hard to slow it down.
I do like the 4 coils. The 4 coil design, it looks like you have plenty of opportunity to inject your necessary magnetic flux into that rotor. I don't know what the rotor is, though. It looks like, either steel or plastic, but I'm sure there's
It's a plastic. It's the wheels you use on the, the walkers. It's a walker wheel. Basically, I retrofitted it. It had really good bearings on it. Built the 3D case for it with ceramic bearings. And it's like almost no friction whatsoever. It's so balanced. And it spins great. No vibration at all.
So do you just have some neodymium magnets glued to the inside then?
Yep, that's basically it.
Walker wheel right here.
So what's your pole configuration? How many magnets and how many poles?
Okay, I never go past 5 magnets. It's always 5 magnets or less. I try to stay pretty close to what Robert Adams was doing. He used 4 magnets. I went to 5 to get, 1 extra pulse per revolution. So, yeah, some of the stuff I think he kind of put in inaccurate for a reason, because he's old school, right? So I think the original blueprints that he put out, I think he left a couple of things out or just kind of changed it a little bit.
Yeah, we see that quite often. People usually do intentionally leave certain things out just for the sake of kind of monitoring what's going on and maybe not giving giving away something that will put them in danger.
Oh yeah, he was already threatened at that time. He tried to patent it in 1977, and it was declared, military property. And they told him to dismantle the motor, otherwise he would have some big problems. You know what I mean?
Oh, yeah.
So he pretty much went into hiding for the next, I think it was 10 or 12 years, and then around 1992, he said, "Hell with it! I'm just going to open source it and put it out there." So he knew he wasn't going to get anywhere with it. They seized the patent on him, so he just said, "Screw it," basically.
It's
And there's been
unfortunate that the same story is shared by all too many researchers in this category, not just for energy. I mean, energy is obviously a huge thing. It's 1/5 of the American economy at minimum, and so clearly, if you're threatening some interest, you've got a lot of money behind it. 1/5 of the economy is pretty large, but other parts of the world, nevertheless, just the energy aspect alone is enough to make you suspicious. But then when you talk about propulsion, gravity control, and you add the other various fun factors of what comes along with understanding these fundamentals, now things get really interesting.
Yep, way too many people have had that problem.
Way too many people are not here anymore, unfortunately. Friends of mine and people that I wish I had a chance to speak with before they had to go.
Yeah.
But we are here, and we are going
Well,
over
you know
it
what?
and
I think
figuring it out a bit of time.
I think the overall, the way it's accepted now, it's better off now than what it was 25 years ago. A lot less people are disappearing. You know what I mean?
I
So
would say that, but I've
well,
had people recently disappear. I mean, it's not necessarily done.
Oh,
We thought it was done, but it's not
like
over yet.
hearing that. Damn.
yeah,
All right.
I don't say it's out of the question, but it's being done very covertly.
It's far more focused now than it used to be. I can say that. A
Well, I
lot
think
less interest with a lot more power have really been kind of focused down into what specifically they don't want out and who they're going to affect. I will say it's nowhere near as wide ranging as it used to be. You don't have to really worry about playing with certain things anymore because they're simply out there. So unfortunately, it is still something that anyone doing this kind of research needs to be concerned with, at least, cognitively aware of, because we still have all kinds of hacking and all kinds of issues going on. It may not even be local. It may not be, some.
What if they just discover their own interdimensional way out?
Oh, I don't think they're looking to try and capture something that we have. I think really it's more about making sure that this does not make the front page of any particular big media outlet.
Yeah, the last thing they want is, you don't have to pay $500 frickin' a month for energy bills, which are ridiculous, because you can take it all out of the ground. And if you ground certain batteries, that they recharge and get extra voltage. And
well, I think the fact that the internet's out there, a lot of the information's out there. People are building stuff in their garages and their basements more and more, and I think it's just the fact that everything went open source. A lot of it did. So there's bits and pieces, little tidbits all over the place, and if you find all the tidbits, you could probably put a system together that's quite effective.
Absolutely. That's one of the things that Rife and I were speaking about earlier is medbed technology, and it's something that is not immediately on the edge of the horizon, but it's coming along. And a medbed would combine a variety of different technologies.
I've seen some prototypes of like the Keshi ones that have like well, where's the coils? Hold on, sorry, one sec. Like these sort of coils but there's like literally I think it was 81 of them in the system that was like fully encased the entire body that they would then run the currents in the. So it was like a triple solenoid times 81 of them. So it was a lot. I don't know what the results were, but apparently they're on the Keshe Foundation's testimonials.
Well, I mean, that would be one possible technology. The alleged or claimed Keshe plasma induction.
So what? Another aspect of it, though, that's claimed with it is that you're nano coating them, so you're breaking down the outside layers of it, and then you're also coating it with your amino acids that you've reproduced in like this electrolysis monoatomic reaction. So you're like putting your own biofield onto these coils that you're then broadcasting the energy and frequencies through.
I hear what you're saying. With the subtle energy ideas, then yeah, maybe there could be a biofield, and maybe someday we will actually be able to detect it, measure it, and quantify it. As far as current technology goes, even the best of backyard inventors who are trying to perfect this stuff have yet to create a measurement system for biofields. But what we can say is that we understand nutrient exchange within cells, and in a healthy body, we understand the need for certain materials.
I would argue that the alchemists and the sages and like the chi masters of the Orient have mastered the science of these energy fields. But
see what I can
completely different rabbit hole.
See what I could add to this too. Don't forget, look at Tesla back in his day. They didn't have amp meters. They didn't have multimeters. He didn't have any of this stuff.
Oh, they had all those things, dude. Of course they did.
What, amp meters back in Tesla's day?
Yeah, dude. I think this all happened long before Tesla. That was some of the very first discoveries. Was that, hey, it turns out this coil, if you wrap a conductor in a loop a couple of times, that it will divert a needle. And
no, I'm
that
talking
is literally the basis for an amp meter. You basically have a magnet and you have a coil, and the two deflect against each other.
He's talking like today's like diodes.
No,
and
but
transistors,
yeah, like all Tesla had basically, all Tesla had was basically brass and wood. He didn't have
you should have read Tesla's notes, Mike. I'm sorry, but I got to correct this one. You should have read Tesla's notes. There are so many notes. I've read over 750 pages of Tesla stuff. He had all the equipment.
Are they on the
exactly what was going through it? RF meters.
Google
Sorry,
Drive.
you got cut off there.
Reading these. I want to read these. Sorry, Jeremiah. Do you know if they're available on that Google Drive of?
You said read these, but I don't know what these are.
Some of Tesla's writings and stuff, like the extra journals and stuff that you're talking about.
There's a lot of fake Tesla stuff out there. Be careful.
Oh, when you read real Tesla, you know it's real Tesla, and you see it instantly with the diagrams.
Absolutely.
So I found out Arthur Matthews was Tesla's last assistant, and apparently he was a huge disinformation artist. I did not know that. And I found out from a pretty credible source that he was. So some of the stuff that Arthur Matthews was talking about. But as far as I understood back in the day, Tesla didn't have a lot of testing meters to measure a lot of his stuff.
You'd be surprised.
I don't know. That could be conspiracy theory too.
He was going up in voltage and stuff that he was using in like the higher amounts as opposed to smaller amounts, right?
Like I said, I would mention, Mike, that you read some of Tesla's notes, because you're gonna see really like all the rumors about Tesla. First, the biggest rumor, the one that really bugs me, that I believed when I was younger and came to understand was completely BS later on, was this idea that Tesla wasn't a note taker. He only visualized things in his mind. Okay, that's BS. Tesla had a unbelievably excellent visualization ability. He could see things in front of him three-dimensionally, rotate them, run them, shift them, consider wear on parts, all this stuff right in front of his eyes. It's something that I share with him in that same sense, where just by hearing about it was like, oh, this is what caused me as a child to just fall in love with this idea of this brilliant inventor that had pushed the boundaries, right? Because I'm like, oh, this guy thinks like me. I'm also the only one in my class that thinks like this or sees like this or just kind of lives in this almost semi-separate world of my own thoughts, right? It's not exactly the outside reality. But
as far as I know, he did have a lot of notes, but a lot of them were lost or taken away. I know that
we still have over 750 pages of his notes that have been retrieved and recovered, some of which didn't have to be recovered, but a lot of which were, and took FOIA reports and all kinds of stuff to finally get back in. But it's been pretty well documented now. So what I'm really trying to point out here is that, Tesla took a lot of notes. He actually did far more math than what most people might consider. He had a working physics model of his view of the universe that was quite in competition to many other models. It was based on the discoveries that came before him and his own testing and experience of those things. So he had differences in his beliefs between Faraday's laws of induction and how he looked at the process of induction. He had different beliefs between Maxwell's equations and how he thought that different things worked. He had hugely different beliefs between relativity, Einstein's ideas, and particle physics. He wasn't even sure if the electron really existed, but he did see the function in what we could call an electron, or the electric field, being transmitted from A to B and having a highly directional vector to it, and seemingly some amount of energy carried with it. But it's certainly more than just a plain photon. So he had lots of different ideas that were scoped based on what he had personally discovered through experiment. Not read in a book, not calculated from some mathematical idea, but literally had been able to produce, observe, and repeat. And so this was Tesla's view of the world, and it was very, very different than what was around at that time. Because let's face it, I mean, the man was making lightning bolts in his lab. He was pushing huge amounts of power through things that were never before seen. Because there wasn't enough power available, and he needed more, he had to invent a new machine to make more power. And then he pushed it to its limits, managed to fry a few, replaced them for Westinghouse, who he was working with, which was the manufacturer to supply all the materials and generators, and then upgraded those machines so he could push even more power through them. So long story short, though, Tesla's view on how all of this stuff worked is very different than what we read. He did take a huge amount of notes. You can actually find his equations and calculations for the inductance and capacitance of his resonators for Wardenclyffe Tower, for Colorado Springs, for his New York lab, for other experiments. It was quite well documented. It's just unfortunate that we don't have access to all of it. But he did take quite a lot of notes. He was not simply a visual thinker as an eccentric that couldn't match today's scientific prowess. He was right there on the same level with everyone else.
Yeah, I think a lot of his stuff was hidden. And I think take an act of God for a lot of it to ever get released.
I'm sure Ben Rich would agree with you.
Yeah. Because I personally think, a lot of people like to downplay what Tesla was actually capable of doing. I kind of think the other way. I kind of think that Tesla scared the Wall Street guys so bad that they had to shut him down.
He scared them and the physicists. Let's put it this way. In an interview, Tesla had made the quote that, with sufficient energy, and he could create a machine that would crack the earth in half. Now, that got wildly popular out there, and let's just say no one ever asked him to prove it. In his time, people knew what he was capable of.
Yeah.
We've just since forgotten.
Yeah, it's just, time, right? But he definitely scared the Wall Street guys to the point where they had to write him out of the history books in any way they could. Like even in schools today, do they talk about Tesla? No. He's been totally written out of that history.
I guess I would have to ask a modern day student. I know that in school I did not learn about Tesla, and my science teacher basically asked me to teach the class when I brought in a huge high power transmitter Tesla coil. So I taught the electricity unit for that, and then let's just say we added a part of the curriculum for wireless power transmission that I think hopefully the students of my small class would continue to benefit from to this day. But I don't know. I would like to know if they yet teach Tesla. I haven't met a college student yet that has been personally interested in this beyond the textbook that doesn't know about Tesla. And even out there on the street, I mean, most people know about Tesla. Elon Musk, at minimum, has at least caused people to look into what that name means and accidentally stumble across who it's based on.
Right.
So I would say the name's out there in a lot bigger way. Of course, the mystique and that wizardry side of things, that still hasn't been fully quantified. Yeah. So people don't know exactly how big Tesla was, but if anybody looks into it, the information is certainly there. If you want the real secrets, though, you're going to have to dig.
Yeah, you have to dig real deep. Yeah, that's the problem. So, with the available resources,
work,
with the resources
that together.
Yeah, it's the resources that we have available. We kind of have to pick up the little
Jeremiah,
pieces that we can find, right?
Yeah, and speaking of which, Jeremiah, do you have a link, or can you get a link later for some of these original writings by Tesla? I'm sure both me and Mike would love to read them, as would probably half the people in the chat right now.
Well, they're not out there posted somewhere where you can just go and download them. We have them on our servers, but we would have to find a way to make them available. So a lot of them have popped up and disappeared, and some of them have popped up again and disappeared again. So we just keep a record of these things when they do become available and save them. I'm not sure how we would go about setting up a public server where just random people.
We'll try getting some on some Discords.
That might be an option. I suppose I could leave that task to you if you wanted to try and distribute data out there. We'd have to set you up with some kind of connection where you could re-upload it to a separate server and maybe.
Yeah, I'm going to be working on setting all of that up here. I got a few things on the go. There's so much work. It's a never-ending list, but it's getting done, and the community is helping with it, and it's awesome to be a part of.
I guess what the moral of this story is basically anybody who's out there listening to us or other inventors is get on the bench, make the stuff. Just don't talk about it. Try to take some easy schematics you can see online, see what other people have done, and try building it for yourself. And you'd be amazed when you start seeing some of the effects and you start going in that direction. It becomes an instant addiction. And it takes you over.
My 4 best words of advice for anybody trying to do home research, experiments, or literally anything else to unlock the secrets of the universe, and they are these 4 words: assume nothing, observe everything.
That's right. Yep. Exactly.
Follow that basic 4-word principle, and you will unlock the secrets of the universe and nature in front of you.
Yep. When you get somebody that's green and they go into it with a non-bias kind of approach, they don't know what to expect. But if they have some notes to go by and some schematics to go by to kind of give them kind of, those little building blocks to get you to a point where you start understanding the systems that you're creating, you'd be surprised what you can come up with. And sometimes you'll discover something that nobody else has done. And sometimes
absolutely. It's amazing, all these little hidden quirks and characteristics of systems that are very well replicated and reproduced, but simply nobody ever looks through these quirky little things. Yep. I noticed this when I was much younger, playing with a Tesla coil type of circuit. This was before I even had built my first Tesla coil. I had no idea how much of this stuff worked, but I did have parts from a microwave oven, and I had a neon sign transformer. So I, rigged those things up and hardwired a power cord. We call it a dead man's cord onto this thing. Wires were hanging all over the place. Extremely dangerous setup. But I had a rectifier diode, which I didn't know what that thing was. It was just this little black rectangular looking plastic thing that had an arrow on it. I'm like, okay, well, that's cool. Maybe electricity goes in that direction. I had no idea. So I noticed, though, that one of my 2 electrodes in this spark gap I had set up with this diode in series, one of the 2 electrodes got really hot, and the other one didn't seem to heat up much at all. And I thought, well, that's super weird. So I ran it to the point where my positive electrode was melting, and my negative electrode seemed to be just perfectly fine, glowing purple. Never did quite understand at that time, what that was all about. Now, come later on, many years down the line, a couple decades, I now understand exactly what was going on there. And this is our difference between cold and hot electricity. So here's the thing. Brownian motion is what we generally use to measure the amount of heat in any particular atomic system. Brownian motion is basically how much individual atoms within a lattice of a material are bouncing around. It also includes gases and plasmas. But Brownian motion is the amount of motion of individual atoms between each other. But here's the thing. Atoms don't interact directly through their nuclei as a primary cause. They interact mainly through their electron shells. Now, this is why ions act a lot differently when we strip them of electrons, positive ions specifically, is that they don't have enough electrons to balance that out. So now here the nuclei actually do start to interact. But the electron shells are a lot wider. They're far on the outside. And so they're going to be making electric field contact with each other far sooner than the time between when the nuclei, the protons and whatnot, will be making contact with their electric fields. So what we can recognize here is that most of the Brownian motion transfer between atoms, and as we could measure in a system, is based on the idea of neutral particles, non-ions, that transfer their kinetic momentum through their electron shells. If we ionize a gas, a solid, a material, as in if we strip it of a certain quantity of electrons or add too many to it, we now have a different kind of property, because now we can transfer Brownian motion in a very different way. We can take the kinetic acceleration from more charges that are negative compared to those that are positive and produce a wave that's radiated and lost from that system. So if we radiate out the heat or the kinetic motion of electrons bumping into stuff and causing heat, if we radiate that out into the environment, when that cycle is done, when everything comes to rest, it's lost some kinetic momentum from its system, and so now that conductor, or whatever radiated the energy, is going to actually end up being colder than the surrounding environment because it's lost kinetic momentum. However, if it doesn't have enough electrons, like say you have a wire that's net positively charged, not just on the positive side of a battery, but let's say you actually positively bias the entire thing with a high voltage, it doesn't have enough electrons. So now instead of being able to flow over the surface of the outside of the wire or transfer their electric fields, they actually have to flow between the spaces of atoms and be flung from one atom valence to the next. This means that they're going to transfer some of their kinetic energy into the protons and into the rest of the atoms. And this is hot electricity. This is the kind of electricity we normally utilize because we ground things. We connect them to a source where all of their extra electric potential caused by the motion of the negative charges becomes neutral with the environment. And so we're just relying on the idea of these negatively charged units flowing through the conductor. And this will inevitably lead to internal conductor friction and an increase in temperature.
And that is where the vast majority of inefficiencies in our current electrical system happen, and that is a complete waste. Like, if we were able to design and engineer all electrical appliances and just electronics to be using and transferring and operating through cold electricity as opposed to the hot and the resistance and heat loss that happens from it.
Exactly, but here's the fun, magical thing that we can do is we can take a system that either uses some mechanical moving parts or maybe uses electric fields in the core or something else like that. As long as we can basically take our conductor, whatever it is that we're using to convert electricity from one space to another, and we can make that entire conductor carry a net unbalanced charge. So let's say we make it far more negative than the surrounding environment. Well, what we're going to end up doing is radiating off more of the negative electric field from those highly mobile particles we call electrons, if you even want to use the word particle. But from these highly mobile charges we call electrons, they will radiate off their field anytime they move. And so if we radiate more energy than the amount of energy that flows through our circuit, which always must be balanced and is 100% of our measured power, then we must have an influx or an inflow of power to neutralize the lost energy in order for conservation of energy to be maintained. And so that means it must come from the environment. And the easiest place that we could say it easily comes from, thanks to the fact that some things get colder when they run, is Brownian motion from the surrounding space, from all of the materials, the atoms and the gases and the solid materials that are radiating off their energy.
Yeah. Guys, it's 11 o'clock my time. I do have to get to bed. I got to work tomorrow, so.
Fair enough. Good, Mike. Thank you for joining us tonight and on this discussion. One more time, this is Mr. Mike, Faraday Research Energy Channel, and I will post the link in the live chat. Thank you, Mr. Mike.
Yeah, thanks, guys. Thanks, Jeremiah.
Take it easy, Mike, and have yourself a good night. We'll talk soon.
Yeah, we'll chat soon. Take care.
You too, brother. Have a good sleep.
Take care.
All right, so I will be ending it on Mr. Mike's channel right now as well. As we were live on Mike's Faraday Research channel for the first time. And now it has stopped there, but still live on my channels. Make sure you go give Mr. Mike a subscribe. All right. Mr. Jeremiah.
Yes, sir.
I've got a couple of other tabs of cold, clean energy and your thoughts. Did you have further thoughts before I continue on with these other stories about the difference between hot and cold electricity and generating it?
Well, I don't know if you want to watch the chat for questions. I'll answer questions. I suppose in closing thoughts, the idea between hot electricity and cold electricity has to do with two principles. I'll break them down just real quick now. Hot electricity is the type where electrons flow through a conductor and have to physically be transmitted between valence shells of atoms. And cold electricity is the type where the electric field of mobile charges is transmitted in the region around the outside of, or the general space around the conductor. And so a resultant radiation or loss of energy occurs during the input event, and an influx of energy has to occur leaving the original conductor during the original event at a colder temperature. So there's your difference between hot electricity and cold electricity. Cold uses the fields, hot uses the physical resistance and conductance of your conductor. And with that, feel free to go on and whatever else you want to ask before I jump off.
What are you building next, my friend?
Oh, man. Well, that's an answer that involves quite a bit of this.
Right? We'll get another 3 days straight if we're to actually force you into that answer right now. Just kidding. What would you like to share, or do you have anything?
I'm not going to go put on anything with camera right now. I'm quite in the... So here's what I basically have going on at the moment. I am reorganizing my entire lab space. I expected it to take about a week. It's actually taking a little bit longer than that. I've installed new shelving, made a bunch of new custom boxes to fit that shelving, created brand new categories, and I'm going kind of through everything to optimize my workflow because of the new categories that we're getting into and some recent discoveries that have really pushed the boundaries. I have right now, as far as active projects go beyond the lab reorganization, the one that I was just playing with earlier today, it is an electrostatic rotary converter. And the reason why I'm particularly interested in it is because this is going to allow me a very high factor of voltage amplification with a simple mechanical prime mover. And in this case, my mechanical prime mover is a small CD-ROM drive motor. It draws about 10 milliamps static at roughly around 4.2 volts, so I can run it off a single lithium-ion battery. And that's a pretty minimal amount of power. Still too much for what I ultimately want to do, but I'm using electrostatic fields that are moving on a disk to induce fields into a stationary disk and stationary electrodes. And the great thing about it is, unlike all previous influence machines, this thing has no brushes, no commutators as far as the high voltage output side. So there's no frictional moving parts, there's no transference of charges between moving part to stationary part. We get rid of all of these mechanical losses, and that's going to be really awesome. What it allows me to do is not lose any of my energy trapped in the circuit, but simply to move it around. And it also offers another possibility. See, if you have, let's say, I'll give an example. If you have a parallel plate capacitor, just everyone imagine two circular discs made of some conductive material, and they are placed some distance apart. Imagine that you can just fit your finger between the two. You put some high voltage across them, right? So if you charge those two things up, what's going to happen is you're going to take some negative charge from one plate, some electrons, and you're going to stick it on the other plate, or take some negative charge from one disk, put it on the other disk. And let's say they're 1 finger distance apart. They'll have now some arbitrary voltage. Let's just call it 1,000 volts. When you go to separate those two plates, the potential between them, the voltage that we'll measure on a meter, goes up a lot because we are inputting mechanical energy. Now, technically, the negative plate still has just as many extra electrons as it started with, and the positive plate has lost just as many electrons as it originally lost. It's not gaining or losing. Neither plate's gaining or losing anything, but the potential goes up because we add mechanical energy. In this system, what we're effectively doing is, when we have two oppositely charged plates, if we were to not use the mechanical energy gain in voltage between these two plates, if we were to simply let go of them, they would then attract back towards each other and return the mechanical energy we used to separate them apart. So what this system does is it basically takes charge between two plates that are close together, it separates them apart, but as it separates them apart, it brings a separate set of two plates closer together that started with the same charge, so it just exchanges charge between two different sets of plates so that no total charge is ever lost. It only changes position three-dimensionally around this rotor, which means that we're not ever killing the dipole, as Bearden would say. We're not actually using any of the charge difference or causing it to be canceled out. We're maintaining that difference the entire time. We're just simply changing which plates it happens to be on at any given time through induction. And this means we have zero lens forces. We can now generate output potentials that are not directly linked to the source that produces the changing position. And because the changing position doesn't actually draw any power from the prime mover, the only thing that can leg us down is when we draw power. So as long as we draw power at the right times, we're not even loading down the prime mover. This is the idea that I'm playing with, because I believe it may be possible to generate a continuous prime mover by feeding back the system and simply utilizing the Brownian motion difference for those charge velocities.
That's actually so huge. And with such a system that you're describing, how would an antenna up with like a balloon into the atmosphere connecting, for instance, a coil, be for a charge into that system?
I'll negate the coil for this example and just talk about the ion collection. So here we have the opportunity to move charge through the system. in a singular direction where we're neutralizing ions, which are positively charged coming down from the upper atmosphere thanks to solar excitation. And we are neutralizing them against the ground potential, which is negative. So we can flow electrons through our circuit from the ground up into our ionizing antenna in a single direction. Now, if we can use that direct current, it's going to be kind of difficult considering that there's very little current there and there's lots of potential. But if we can cycle that current that's available in pulses, we can increase the current while, you know, basically compressing the potential, and then we can down convert it to a voltage where it's useful for powering our prime mover. So it is possible to trap it, and it wouldn't take that much extra input considering the efficiency of the system is already about 99.8%.
Just like 98% just like, it's insane how this, oh man, I don't want to go into a rant, but the promises that these experiments and developments have are revolutionary, and it's awesome to be listening to it and a part of it, good sir.
Yeah, what I can tell you is if I get this thing self-oscillating and self-operating, you know, free from the environment, but perhaps using an ionization antenna, I will certainly not say that's what it's doing, and I will probably just tell everybody a hypothetical idea on what they might do to build it.
Fair deal. What are your thoughts? I was playing some of MTech Industries work and research.
Yes,
What's your
energy
thoughts?
researcher at now MTech Industries. I have been watching his videos and seeing his recent developments with his modified magnifying transmitter. I have a few issues with it, and I have lots and lots of praise for it. He has taken a simple circuit, the Slayer exciter, modified it to the point where it's become effective and efficient. He had to modify it because his frequencies are lower and his output power is much higher, so you can see that he's using inductors to slow down his signal so that he gets a correct impedance match for his power supply at the frequencies he's running, and also has some kind of internal current limit that does replenish. He has, I would say, optimized transmission distance for an extremely low power system. He is definitely on par with some of the best that I have done in terms of his transmission range versus radiated energy. So I would say it's pretty damn good. I have a system that's spark gap based, which I'm not going to speak on in terms of its efficiency because it is spark gap based and it's highly lossy. So most of my energy, I know where it's going. I'm radiating it out in a way that I cannot capture. But I've got that system beat quite a bit with the spark gap device. Otherwise, though, my solid state systems, I would say that he's just a little bit more optimized with this singular system he's been developing here than what I have right now.
And that's what it's about, is like learning from everybody's experiments and developments and ideas and applying it to your own and sharing your own with others in the community working on it.
But I would definitely recommend people watch this guy's channel, take a look at his videos. There are some long ones. A lot of them are actually short enough to digest. Just take a general look at how he walks throughout his house and basically can touch any grounded point because of the capacitance of his body, and his transmission potential is high enough where within his place, which is obviously on ground level, as we can see right here, it's on ground level, so is the rest of his place, that he's picking up this potential even against the capacitance of the ground with his body. So this is kind of significant, especially considering some of these devices, they're 9-volt battery powered. Well worth a look, well worth replication too. He does have some videos. You got to kind of scroll through them to find the ones, but he does have some where he actually shows the schematics of his other devices, and he understands, I think, to some extent, the importance of balancing the copper mass.
Yeah, and he said that he'll be able to come on one of our last Year of the Coil episodes before going into Year of the Superfields, which everybody is looking forward to. Gerald did a couple of new videos on water today. What are your thoughts on? Did you get a chance to see those yet?
I did. I mean, we know initially he's using enamel insulated wire, and the idea of what he's running as far as LED strips go, I guess I kind of have to consider the fact that I've seen other experiments by him which weren't aired, but his impulse is very fast. It's fast enough that the resistance of the water is almost negligible. It's also fast enough where the likelihood of actually being shocked by it is pretty darn small. This thing generates far more field than it generates in terms of electrical output, and that's one of those parts of his systems that aren't too well looked at, but it's really the field dynamics that do most of the work here. So his recent videos, he does show that even with the extra capacitance of the water surrounding his coils, it doesn't negate from its ability to produce an extraordinarily fast pulse and produce the output power that he uses to run loads.
I see. Thank you for clarifying the exact relevancy of the demonstrations. And now I've got
in the simple sense, I'll also say, like, oh yeah, this is ball lightning. But in the simplest sense, I'll also say that generally he's showing these videos because it's considered a bad idea to add high voltage impulses to water or just high voltage to water at all. And here he's showing that this type of power that he's generating, it doesn't really have a problem with it. So that's one of the things that he was trying to demonstrate.
Cold electricity, essentially.
It is. His coils don't get hot, and a lot of the experiments that I've done that have to do with what he was doing, they also don't get hot.
So most coil energy is cold electricity that it's radiating and dealing with, and the water is a great demonstration of it.
I wouldn't say most coil energy, but I would say an ideally designed coil.
Sorry, cold electricity. I meant cold electricity.
Right. I'm just saying not most coils. Like that purple coil there, we just seen on the left, that big coil right there in our video. That's a big coil. Right? That coil is not cold electricity.
Don't accidentally shock yourself. Yeah. Sorry. And
so that coil is going to get warm. That solenoid coil, poorly wound. Yeah. In this video, what I'm showing is that there's two different modes of operation for the ionization of the gases inside of a neon bulb, and one of those modes of ionization does something extraordinary. It produces a spherical ball of plasma between the electrodes instead of a uniform flow discharge, and that spherical ball plasma has interesting properties, and one of them happens to be that even though the ball of plasma tends to be carrying about 100 times more power than the average glow discharge of a neon lamp, it doesn't seem to cause heating in the neon lamp. So what is it doing with the energy? If it's consuming 2 orders of magnitude more power and producing a significantly huge amount of light and also somehow not heating up the electrodes? It is quite the question. And so there's the transition we're looking at there. This is where our neon gases are starting to produce blue, and that blue is not coming from the excitation of the gases directly, but actually coming from the collapse of free electrons falling back into orbits as they're reabsorbed, since they've been completely stripped away, circulated, and freed down. So some of that blue light is actually coming from something called Bremsstrahlung radiation in this case, because of the internal current, but technically you would think of it as synchrotron radiation. It's just a single oscillation.
Okay, that's absolutely fascinating, because I was like so taken back by the blue and red alternating plasmas, and then how it eventually like merges into a purple from like going back and forth so much or something like that. It's
yeah, the plasmoid, this self-structured little circular or spherical kind of plasma between these electrodes, is a really much more complicated structure than we might assume. It's not simply two tiny little points on the electrodes that now have this big excitation that kind of surrounds them uniformly. That would be more of a football shape. But in this case, this thing goes spherical because it's got lots of independent geometries inside of it. It's wrapped up with many, many microtoruses on top of each other. And because there's so much kinetic energy in there, you now have much more electron momentum than should otherwise be present in that volume for plasma. And those are, of course, radiating off energy. And that's where the cold comes from, because they are dissipating it out into the environment. And as a result, they are changing the local scalar potential. When you radiate off energy from a charged particle, and you don't have an oppositely charged particle also radiating off equivalent energy in the same volume of space, you end up with that volume of space having a leftover scalar potential that is not uniform to its previous previous state. And this does create stresses on that local space and time. And now we're getting into warp drive dynamics with that one.
Well, that means fields and super fields and the whole new series that is to come. And that first, we are understanding coils and electricity and the difference between them. And this right here is part of the Hutchinson's crystal battery cells and the smaller versions that Nancy and John have got them down to. And we're going to have Nancy and John on this weekend for a segment of the Science of Sound series episode where Nancy is experimenting with layering overtones of 432, 440, and 444 all on top of each other, and the possibility of, I guess, portal superfields, whatever the time dilation, all sorts of higher dimensional interactions. It's interesting stuff. Interesting stuff. What are your thoughts on that, good sir?
Well, portals, yes. Portals generated by a little Bluetooth speaker sitting on somebody's bed with a incorrectly oriented.
I'm talking down the road.
Yeah.
The basis of it, not. Yeah, sorry. I'll let you continue.
Yeah, on that one though. I mean, that video that the guy sticks this little LED Bluetooth speaker on his bed and allegedly creates a portal.
That's also what that supposedly was of. Campbell.
Yeah, a single speaker, a single woofer is not going to be able to create those kinds of interference patterns. Just not going to happen. Sorry.
I agree with you on that.
No, I'm actually quite interested in the new series of interferometers I intend to build. These laser interferometers that I've currently been using have been incredibly useful in doing the gravitational experiments. And one of them has recently given me a remarkable result. And I'm not going to say exactly just how far we were able to delay the fringes, but it was significant. And the ironic part is we just used high voltage electrostatic fields and accelerated electrons to do this. So I was really, really shocked by it. I didn't expect the accumulation effect to sustain itself over time, and I didn't expect the decay to take 4 times longer than the buildup. But holy cow. We got some significant displacement in that local space from the interferometer readings. And then now it's just like, it's going to take 4 times longer, 5 times longer to undo those readings and figure out why it can't be right and why there's no way that's actually what happened, and how we definitely didn't really displace space-time and distort the local velocity of light, because I've got to disprove it in every possible way that we can think of in order to really say, oh, yep, this is exactly what it looked like. So far, 8 experiments in, I still can't disprove it, but I can certainly say there are a series of line items where things just don't make much sense. And one of them happens to be the orientation to Earth's gravitational field. This thing actually does make a difference with whether it's right side up or upside down. Even though the beam passes through the same physical space of the device, it makes a difference in one direction versus the other. And that's something that I haven't figured out yet. Still trying to unravel that little mystery.
And for the day you do, it's like, did Jeremiah get taken, or did he disappear on his own accord? And hopefully you come back to us. So don't enter a portal that you can't. It's unsustainable. You know, like you have to be able to come back through it.
If this thing did make a portal, it would be about 2 millimeters wide, and I'm pretty sure I cannot fit through there.
All right, well then, I guess just enough to send a pinprick.
Well, a beam of photons in this case.
Fair enough. My question, so we were discussing the potential of using like a paper towel or something along those lines of a layer of this crystal tartar of the Hutchinson crystal battery cells, and then the circular shape and the surface area helps. So I noticed Charlie's models he used, and many of them used aluminum as the cathode, that essentially if you had copper coins and then just like the bottoms of aluminum cans punched out, and then your paper towel or your cloth layer saturated in the crystal salt sugar mixture, if it made a stacked battery, essentially the old stacker styles, only, oh gosh darn it.
Huh.
Oh, did I load it to Twitter? I think I hadn't loaded it to Twitter yet.
For voltaic piles, what you're referring to?
Yeah, voltaic piles. Yes, that's the term.
Yeah, a stack of individual plates, each of which have a different potential, and then can be added on top of each other. So I just got a 10 millimeter hole punch in today, and I'll be using that to create a small voltaic pile. Not particularly why, 10 millimeters is not going to provide me much current, but allegedly there is a configuration where these things can produce reasonably high voltage, upwards of several hundred up to over 1,000 volts, with say about 100 and something layers. So I have every intention of testing to see if that's going to be valid, and also checking to see what its orientation and gravitational mass is in its response to receiving other external fields, if it does have a general net bias on its own. But I'm not sure about the Hutchinson stuff yet. I have yet to test their mixture. The idea of using the stamp, that 10 millimeter size, is that I can create sort of a standardized test. And so instead of pouring this kind of pasty mixture between copper and magnesium in some of the Hutchinson cells and some of the replication cells, or aluminum in other metals, or carbon, in this case I can actually just stamp out little discs and have a fairly standardized measure. So I will be soaking a fibrous mesh in that normal pasty material that is
exactly right,
different metals, and this will allow me a really consistent way to construct it.
Potentially, also between the metals and that mesh, one layer of like a wax paper or something that separates the charge as well, correct? And then you'd be wiring one on each, a little connection between the stacks above and below the layers of the wax paper, and that's, or the insulators. And
the cream of tartar mixture in the Hutchinson cells massively popularized design is going to be soaked into that mesh, so that will be my quote-unquote electrolyte layer, or my reactive layer. And the wax paper, if I end up using anything that's a non-conductor at all, or a non-permeable membrane, that will have to be figured out yet. But so far, it's just going to be a matter of metal differences and making sure that I have my active layer space between my two dissimilar metals, and they're all arranged in that sort of pattern.
Right, and that the differential between the different elements is what's giving you your charge generated between the crystal mixture, the salt,
right?
Sugar mixture.
I honestly don't think it's going to end up being something that's fume of tartar and mixed up with water, but I have other plans for shell salts and crystals that are custom grown to be sliced into thin little wafers and then pressed into this stack. I would very much like a completely dry system, and to see how much that can actively convert what I guess you call radiant energy or other sources of available energy without having to deal with this whole the cell breaks down and catalytically destroys itself over time.
Yeah, absolutely, right? I feel you on that. Because you want something that lasts, not a pain in the ass that you have to keep replacing.
Yeah, I forget what is it, like over 116 years? I don't know the exact number, but well over 100 years that bell ringing circuit battery continued to provide. And I guess recently it stopped or something on those lines. Not sure. I'm sure it still has potential in it. I could be that could have just been YouTube algos trying to advertise to me a video that I never did actually click on or bother to watch, saying that. I guess now it's stopped, but it was a freaking long freaking time, since we still don't know exactly what's in it because nobody wants to take it apart and figure out what that magic was that kept it working for over 100 years. It's still one of those strange phenomena. But we know that these things can run for a really long time. And speaking of long time run, my ultimate goal here has nothing to do with these idea of stacks that are voltaic piles, but to do with direct conversion of nuclear decay energy into usable power. Right now, we boil water with nuclear decay energy. We just use that radioactive source to heat up water that can absorb it, heavy water in this case, and then we use the heavy water to transfer the heat to normal water, and then we use that normal water to spin turbines. Really, like it's actually pretty effective as far as capture. It's well over 98% in most cases. So as far as nuclear power stations and nuclear energy conversion, it is really efficient right now, and I'll give it that. But it's also very large. It uses steam and a variety of combined systems. However, radioactive elements like uranium, thorium, iridium, these are materials producing a constant decay of both protons and neutrons. Sometimes they're clustered together, like in the case of uranium-238, 235, you're ending up generating these helium nuclei, 2 protons, 2 neutrons. And with other sources, you're like thorium, you get some of that stuff too. You also get lots of gammas. Gammas are ultra high frequency radio waves. They're basically photons of light by the conventional sense, but extremely short wavelength. And then you get a variety of different types of emissions, like high-speed electrons, for example, and your beta emissions. They're moving incredibly fast. So if you could just capture all of these waveforms, instead of just using them to heat water, if you could actually capture the negative charge of the beta radiation, the electrons coming off of these isotopes, and you could capture the positive charge of the alpha emission, protons coming off of these isotopes, there's real electrical power there. Right now, we don't use that in nuclear reactors or for nuclear batteries. We literally just waste that and try to either make light or make heat out of it. But what I'm working on is a way to directly capture the potential between beta and alpha decay, so we can fully optimize our nuclear batteries to completely eliminate the emission of radiation by converting everything to electrical charge.
That is amazing. Like, Jeremiah, may you be blessed with forever health and stop exposing yourself to crazy radiation while coming up with these amazing devices. And tests, my friend.
We all know, Bernie, that I'm going to die younger than most, but have gotten in that time much more.
The goal should be to die longer than others, like to, delay that life and try to get that monatomic gold or whatever the elixir of life is, that fountain of youth, not let's be myself with lead and freaking radiation from
which I will mention on that note that I did just get a big sheet of protective lead in. It's really wonderful stuff.
Okay, so the thing is, never connect that lead to salt water or electrolysis, because as soon as it breaks down into the monoatomic and diatomic particles, then it becomes extremely, extremely poisonous and absorbable and deadly very quickly. That is the one thing. But other than that, if you shall use it as a vest and shielding from radiation 100% in its solid state, that is great news.
And I guess this would be a valid time to mention that some types of radiation cannot be shielded by lead or bismuth or certain other things. Well, actually, bismuth, yeah, I shouldn't say that. That can actually shield against things lead can't stop. That would be your strange radiation, your electron clusters. So those things aren't really your conventional radiation. When they break apart, they produce extremely shortwave radiation that usually just shows up as a gamma. But they have very different wavelengths and different penetration depths. So strange radiation produced by exotic vacuum objects or electron clusters happens to be capable of being absorbed or stopped by certain materials, and one of them is boron. Boron's a particularly excellent material at grabbing onto these clusters, trapping them in place, or at least absorbing the extra emission. And we also know that bismuth is another that can hold on to these clusters and keep them in stasis for a huge amount of time, which means that as they absorb more, the bismuth metal itself will respond differently than it otherwise would have if it was not holding on to these charge rings.
Sorry, I just need a moment. The wife is calling. Be right back.
Oh, well, we'll just do an intermission because I also need to take a quick dash. I would recommend you play a video with sound.
And the thing actually has a carrying capacity of 1/2 pound, which is insane considering it weighs 1/2 pound. So I built this little wire harness made of fishing line and, hey, acrylic that'll hang about a meter below the drone and carry this electrode up into the sky. This allows me to use the drone's camera to spy on the top of the electrode just to see if anything crazy happens at height. The harness, electrode, and wire only weigh 70 grams, so lift isn't an issue. I'll be using a few tools to visualize